Welcome back to Cloud 42, I'm James. Today we're continuing work on the low profile edge clamping jaws. We made the grippers last time and now we just need to make the jaws themselves. Here's the drawing for the jaws. As you can see, it's just a rectangular block of material with a slot milled out in the top to hold the clamping cleats and holes drilled through it and countersunk to mount it to the vise. So you can see these are the cleats that we made last time, and they fit into this slot in the top, and there's holes that are tapped in order to hold that down. And you can see that we've got countersunk holes set. This is to take the bolt that holds it into the vise and then countersunk so that the bolt head is recessed down inside of it. And this is a sample of the material we're going to use. This is 1.5 by 1 inch cold finish steel. Now, cold finish steel is actually rolled under pressure when it's cold to form it to the final shape. And that's great because you get a very accurate final shape. You don't get mill scale on the outside. However, it does build up stresses. It work hardens the surface and builds up stresses in the surface of the material. And what this means is that then when you come through and mill that strained, stress-laden surface off of the material, it means it's going to move. And so this is one of the concerns I have using this material for these vise jaws, is these seem to be very flat and square. And especially when we mill this slot out in the top, I'm worried that as the stress is relieved, the material will actually warp and move. So what we're going to do is we're just going to try to take equal amounts off of each side. Then we're going to come back and rough the slot out in the top and then measure. And we'll leave it a little bit oversized, and then once we've got that slot roughed out, we'll measure, see how much the material moved, and if necessary, we can then come back and flatten them. Or if it's not necessary, we'll just leave the jaw a little bit oversized. There's no reason to come back and clean it up. Jaws are made from 1 by 1.5 inch mild steel, and the finished jaw is going to be just over 4 inches long. So we need to cut a couple of pieces just a tiny bit longer than that. Maybe 4 1/8. Well, I'm not super happy with that, to be honest. Let me take another 5 off of that and see what it does. not liking that surface finish. Try running the speed up a little higher and see if it's any better. Let's just take 10 thousandths. That is not any better. Okay, that's much, much better. So bringing the speed up and the feed up has given me a much better surface finish on that. Awesome. So that's the recipe. Okay, let me deburr these, flip them, and do the other side. Best surface finish yet. Looks like having more of the cutter engaged helps. Okay, the next step is going to be to finish these to length, which means we've got to side mill the ends of them to get them to the correct length. So I'll set up a stop and a larger end mill, high-speed steel end mill in the mill, and we'll go to town on the ends. This one's high-speed steel, so it will pull out if I don't pay attention. Okay, so I got this set up. I've got a stop in the mill now, and I've got the one jaw set up so that I can face the end with a half-inch 4-flute high-speed steel end mill. Now I'm going to slow this down because this is high-speed steel. Probably should only run it around 800 RPM. so don't really want to burn it up. Okay, let's see how we do here. Just touch off. There it is. And let's take 10 thousandths. See how that sounds. See what the surface finish looks like on that. Yeah, that's acceptable. Let's try a conventional cut and see. Take another 10. It's nice. I'm going to cut the feed down half that speed and then take 5 as a finishing cut on this end. That's a nice finish. Okay, I'm just going to set the X0 right there and pull this out, put in the other one, do the same thing. That's 10. This will be 20. This will be 30. That'll be 40. This will be 50. This will be 60. And then just to be sure, I'm going to take a measurement here. We should be about 35 thou to go. So let's see where we actually are. .4028. So we've got 28 thou to go. So let me take 20 and then we'll see where we are. That's 10 of it. I'm going to take a spring pass here. Okay, now let's measure and see where we are. Loving the new air compressor. Looks like after the spring pass, we've got about 6 thou to go. Okay, I'll dial up 6. We'll take it at half speed. And this should be the finished cut on this one. Okay, that should be right on 4 inches. Let's grab the calipers, see where we actually ended up. 4 inches. 3,999.5. I'll take that. Okay, I have the mill set up. I've got one of the vice jaw blanks in here set up. I have the mill zeroed on the center of the top back edge, which is how I have the cam program set up. And I have a 3/8 inch tank power end mill in here. This is the YG1 powdered metal rougher. So it's a 3/8 inch roughing end mill. And we're going to come in here and try to do a high-speed adaptive to take the material out of this slot. Now, I have never run a tool like this on this particular light mill with this kind of load in steel before. All the numbers say this should be good, but I will definitely have my hand on the stop switch just in case. We're running about 1900 RPM with air and coolant. Wow, that's gorgeous. Because of the load on the machine, the one thing I wanted to do here is make sure we didn't lose steps going across from left to right. 150, 149, 148.5, 150, 149.5. So say about 150.5 there, and on this side it's about 150.5, 151. So we didn't lose any steps. So the only thing I was worried about is every time it pushed, was I going to lose a little bit? Boy, that was beautiful. Let's put the other one in and run it. Now this is cold rolled steel, and one of the things about cold rolled steel is that it has stresses, especially near the surface. So if you start removing the material that has that stress in it, the material moves. Now this is a pretty good sized cross section. It's 1.5 by 2, or 1.5 inches by an inch. So there's a lot of steel in here, but it's still going to move a little bit. The question is just how much. Now I removed equal amounts off of all 4 sides, so it shouldn't move very much from that operation. But then when I cut this groove out, when I rough the groove out specifically, it will move, and that's going to release tension in this side of the part, which should cause it to bow and be convex on this side. Now one way to measure that, see how much it bowed, and decide if we need to do anything about it, is to use a dial indicator on the surface plate. Now I think the concave side is down, so if I put a dial indicator on one end and zero it out here, then if I press on this, it should not rock because it should be sitting on these outside corners. And sure enough, there's no rock there at all. Let me try the other one. There's no rock there on either end. Okay, but this is the side that should be convex. So let's flip these over and get them on the surface plate. That's convex side down, and see just how convex they are. Okay, so you can see that when I press on this, it pivots around the middle. I think I got something under it, under that one. It pivots around the middle, so you do know it's convex. But let's see how much. If I bring this in, put the indicator on it, and then press, one division on this indicator is about 1/2 thou, so that's about 1/4 thou of movement. Should be the same on both ends. There, I must have had a piece of dust under it because there's a good 1/4 thou or less of movement there. About 1/4 thou. And this one's roughly the same. Let me turn the other side in. Lots of dust in the shop today. There we go. Let's have something on this. I measured these earlier. They weren't moving this much. Yeah, I can feel the dust. There we go. It's about 1/4 thou. So what that means is, if I can press it down 1/4 thou on this end and up 1/4 thou, it means it's about half of that, which means that it's just over 1/10,000th of an inch bowed down on the ends relative to the center. Now, and you can kind of see the shiny spots right there. There actually appear to be more shiny spots in the surface finish. You can see there because they follow the edges of the mill. So I think this is going to be plenty. I wouldn't want to try to take 1/10,000th off of the center or worry about 1/10,000th of bow. I could very easily reintroduce that just with my milling machine. So I think these are going to be fine, especially since these slots are going to be roughed out to width, and these are going to be used for cleats to hold down blocks of aluminum for milling on the side that's not finished. So I think we're just fine. I think these will do. Now we just need to go back to the mill, finish out the slot to width so that the cleats will fit in it. It's close, but it's not wide enough yet. And we'll do that with a carbide end mill and then drill and tap holes to hold them. Okay, I have one of the jaws set back up in the vise. Again, zeroed on this top back, the center of the top back edge. And I have a 1/4 inch 4-flute carbide end mill, and now we're just going to finish the slot out to width. I didn't leave any allowance, so it should come out exactly to 501. It probably won't. It'll probably be undersized just because of tool deflection. It won't be much deflection from the carbide, but there will be some deflection from the lightweight mill. And we'll just measure and see where we are and see if we need to take, another half thou or something off of each side to bring it out to size. And now the finish pass. Okay, let's just get crazy and see if that fits. Oh, it wants to. It so wants to. It's so close. Well, let's break out the gauge blocks and let's see how wide this slot really is. Okay, so we're going for 501. Let's just see if a 500 block fits. And I can't make it fit. So let's take a 350 and a 149. That really wants to go down in there, but again, it won't quite drop in. Let's try a 350 and a 148. That goes in, but not to the bottom. Okay, let's try the 147. .350 and 147 go to the bottom. And there's a little bit of motion. Not if it stays flat on the bottom. Okay, so 350 and 147. That means that we're currently sitting at 497. Write that down there. Which means to get to 501, we need to take 2 thou off of each side. But before I do that, I'm going to just run this program again so that it will essentially be a spring pass and scrape out those sides. And let's see where we are on that, because whatever comes out on a spring pass was certainly going to be taken out if we just take one thou. So we don't want to overshoot. So we'll just try a spring pass here and see where we end up. And I know there will be a couple of wasted cycles here, but I'll cut them out. You won't have to watch. Okay. See how wide the slot is. Again, because I'm an optimist, we'll try the 500. Oh, and it goes in and goes partway down, but not all the way. Okay. 350 and 149. Yeah, that goes all the way to the bottom. So we are now at 499. And if we want to go to 501, we need to take an extra thou off of each side. So I'm going to go pump this through Fusion one more time and tell it, set it up to leave -1 thou, and that should put us right at 501. Boy, that's nice. Yeah, but the extra thou, it goes part way down and will not go the rest of the way. Okay. If the slot ends up being 502 instead of 501, it's not going to hurt anybody. Yeah, and these are doing the same thing. They'll go part way down, but not all the way. They are consistent end to end, though. Boy, I kind of want to just take a half a thou off of each side. Yeah, I think that's what I'm going to do. Half a thou off of each side. One moment. Okay, let me load the code for that. Let's let her run. And it's taking some very fine slivers. I'm glad I didn't take a thou. Okay, let's see how they fit. The grips fit in. You can feel the motion. There's supposed to be 1 thou. You can definitely feel that that's there. but there's not much more. Let's actually measure them with some gauge blocks and see where we really ended up. Let's see, so if we go with the 50 1/2 inch, it will just go into the bottom, and I can just barely feel that moving. So if we want to stack up a 501, we'll take the 400 plus 101, and that is very tight. It almost goes in. So we're actually somewhere between 500 and 501, which is exactly where we want to be. Let's see exactly where we did get to. Let's take 500 1/2. That will go to the bottom, but then it's in there, nice and solid. Okay, looks like we're about 500 1/2. Let's try 500.6, 0.5006, and it will not go all the way to the bottom. Great, so we're about 500 1/2, which is just slightly larger than the teeth. So I'm going to call that good. I'm going to machine the other one, and then we'll come back and drill some holes. Okay, I've got the second one now milled out to width. You can see these gripping jaws fit in and they slide freely, but there's very little movement side to side, less than 1/2 thou, which is exactly what we wanted. So I am very happy with that. The next thing we need to do is drill and tap some holes, but that is going to have to wait till next time. If you've been enjoying these videos, please give me a thumbs up, like, subscribe. Thank you for watching.